Okay, so we're going to do an example, and the example we're going to do is of two equal charges which are separated by a distance d. And what we want to do is find the electric field at distance z above the midpoint. So the first thing I'm going to do is I'm going to draw just a little diagram. Okay, so this is going to be our x-axis, and this is z. Okay, so we've got one charge located at some minus x, this is q, and we have another charge located at plus x, and that's another q. And we're trying to determine the electric field at this point above the x-axis. Okay, and here's our origin. Okay, so what we're first going to do is we're just going to write out our equation for the electric field. So our electric field for each charge will be determined as follows. And at the end, here's our unit vector. And what we need to do is we have to find out what our source vector is and what our field vector is. Now remember, our field vector is the point of observation. So in this situation, it's going to be at the point P. And our source vectors are where the charges are located. So first of all, what is our field vector? So our field vector is given by r, and this is going to be equal to z hat. Okay, so this is our point of observation. Now for our source vectors, the source vectors are given by a prime, so we have r prime. And to distinguish between the two charges, for on the negative side and the positive side, I'm going to put a positive, a plus and a minus in. So here's our r prime plus. And this is going to be equal to x prime x hat. Now, although it would be quite easy just to write down x hat here, the notation that we're adopting is that for all source vectors, we're going to put a prime in. So for on the negative side, we're going to have an r prime minus, and this is going to be equal to a minus x prime x hat. Okay, so now what we can do is we can write down our separation vector. Okay, so our separation vector for both sides, so we have an r minus r prime, this is the plus one, it's going to be z hat minus x prime x hat. We've got an r minus r prime on the negative side will be equal to z hat plus x prime x hat. Okay, and our magnitude 10 is going to be r minus r prime be equal to square root z squared plus x squared. And of course it's going to be the same for both sides. Okay, so now that we have these, all we have to do is put them into our equation, or put them into our formula for the electric field. And because we've got 2 point charges, we're going to use the principle of superposition. We're going to add the electric field due to each of them together, and that will give us our total field at that point P. Okay, so let's do that. So our electric field for R is going to be equal to 1 over 4 pi epsilon naught by Q divided by z squared plus x squared by z hat minus x prime x hat by the square root of z squared plus x squared plus, now the other charge, so we've got q over z squared plus x squared by z hat plus x prime x hat divided by the square root of z squared plus x squared. Okay, so that's going to give us a total electric field at that point P, which is the midpoint between the two charges. And what you should notice here is that the x hat components are going to cancel. We've got a minus x prime x hat here. We've got a plus x prime x hat here. So those are going to cancel. And what we're going to be left with is our electric field will be equal to 1 over 4 pi epsilon naught. We're going to have a 2 qz divided by z squared plus x squared to the power of 3 over 2, and it's in the z hat direction. Okay. And what we have here is x is equal to d over 2. So just to write it out in full then, we have r is equal to 1 over 4 pi epsilon naught by 2 qz divided by z squared plus d over 2 to be squared, and d is the distance between the two charges, by 3 over 2 in the z hat direction. Okay, well, we notice it's correct because we have no primes left in our equation. So basically at the end of it we want to have removed all of our primes, and then this will be our final answer. So here's the electric field at some point P on the z-axis at the midpoint between the two charges.